Hello, and welcome back to a video series on MAT 1033 Intermediate Algebra. This is going to be video number 7 in the series on order of operations. So we've now covered 3 operations. We've covered addition, multiplication, and with the last video, we started to talk about exponentiation, although we really only talked about how exponentiation works with positive exponents, or at least non-negative exponents. And we also talked about the opposite operations for the first two, namely subtraction, the opposite of addition, and division, the opposite or inverse operation of multiplication. But we can always write those two operations, subtraction and division, in terms of addition and multiplication. To wit, if we want to write subtraction as addition, we just write it as plus a negative times the thing we're interested in. And if we want to write division as multiplication, we just take the reciprocal of the thing we're dividing by and multiply by that instead. And we talked in the first few videos about how the properties of addition and multiplication are so much nicer than those of subtraction and division that it oftentimes makes sense to do this and actually write things this way. So what about exponentiation? Does that have an inverse? Well, it's not commutative, so it actually has two slots that are each different, a first slot and a second slot. A base and an exponent, and canceling is going to mean different things in different places. So it actually has two inverses, and we're going to have to talk about that some other time because that has its own kind of Pandora's box that we can open up. But we are going to talk about it. At the very least, in this course, we'll be talking about radicals, which is a way of canceling, raising something to a constant power. In subsequent courses, you'll look at logarithms, which are another kind of inverse of exponentiation. But for the purposes of this video, we're just going to talk about exponentiation. We won't be mentioning its inverses. So we already have a way of deciding what to do in the order of operations. Parentheses tell you that if you want to evaluate something first, or at least consider that thing first, you could just put parentheses around it, right? That's what parentheses are for. But if you just put parentheses everywhere, or even the bigger brothers of parentheses that we'll look at later, brackets and braces, it really does start to look quite messy. It's a lot. It just makes the page look very complicated. So instead, what we do is we decide that certain operations are going to take priority over other ones, and we're going to evaluate those first. And it's just an agreed upon order that we do these in. We could have agreed on a different order. There's nothing really that makes one primal to the other. But this is just the conventional and agreed upon order that we do the operations in. So here are some critical notes. Copy this. I want to see it on paper so you can get credit for watching this video. When we evaluate, we go down through this acronym of PEMDAS. We do parentheses first, then exponents, then multiplication or division, then addition or subtraction. Now, I want you to make note of the fact that when we solve, we go in the other order, or we can go in the other order. This will be focused on more in subsequent videos, but for right now, I just want this in your notes. So there's two things in particular that I want you to remember when you're dealing with this PEMDAS acronym that you might not have seen in previous math courses, so I want to state it here. Number one is that multiplication and division happen at the same time. So do addition and subtraction. I see a lot of people who think that for some reason we have to do multiplication first because the M comes first in PEMDAS. This is not true, actually. Remember, division can be rewritten as multiplication. So what sense would it make to say that you should do that first? We looked at how multiplication is commutative and associative. It can be done in any order. So if division can be rewritten that way, why would they have a different order of operations? They don't, right? They actually don't. And it is a mistake to think that they do. A mistake that is actually quite common because people adhere to this acronym quite slavishly. It's not a rule that's hard-coded. It's actually just a mnemonic for remembering the order of operations, and you shouldn't tie yourself to it thinking, oh, the M comes first. Well, no. It's group them together. Think multiplication and division happen simultaneously. Same with addition and subtraction. Number two is what I mentioned a little earlier, that we follow from the top to bottom. We go to the P, to the E, to the M and D, to the A and S, from when we go to evaluate or when we go to plug in numbers. When we're actually doing arithmetic, we go in that order, left to right as I've written it here, or top to bottom as in the notes. Later, when we learn how to solve equations, we're going to see how useful it is to go up from addition, subtraction to multiplication, division, and eventually to exponents and to parentheses when we deal with solving equations instead. It gets double use that way if you can remember that evaluation goes from the P to the S, and solving, we should start low. We should start with the low operators with addition and subtraction and move up from there. But for now, let's just practice evaluating. Let's just practice plugging in numbers and using the rules of PEMDAS to figure out what the final number should be. So let's start with an expression like this. 1 minus 3 times the quantity 5 minus 7 times 3 divided by 2 squared. Okay? So there's a few different ways that this could be evaluated correctly. But here is a way employing PEMDAS. Now, there are a set of parentheses in here. And so we should start inside the parentheses and see if there's any more. Well, there are no more parentheses. There's just that one set. So inside, we look for exponents. There's none. We look for multiplication or division. There is some. And so that's where we're going to start. We begin this process by looking inside the parentheses and then applying PEMDAS again and seeing some multiplication and division to do and doing it. So 7 times 3 first. That will give me 21. Now let's finish up with what else is inside the parentheses. There's a 5 minus 21, and following our rules for negatives, that's minus 16, right? 21 minus 5 is 16, so 5 minus 21 is negative 16. Now, the parentheses that I've written here really are just saying multiply this by the 3. There's nothing left to do inside the parentheses. So we can proceed to the other letters. Like we could say, is there any exponentiation to do? And there is some. So let's take care of that now, right? 2 to the second power is 2 times 2, or 2 twice, which is 4. Now let's take care of the multiplication slash division. So I'm dropping the parentheses here finally. We really are just multiplying by negative 16 in the middle there. And dividing by 4 is just times 1/4. This is what I was alluding to earlier. You really are just multiplying when you are dividing. You're multiplying by a reciprocal. And so, in other words, it doesn't make any lick of difference if I do the 3 times the 16 first, or if I do the 16 times the 4th first. And that's actually probably easier to do. It'll keep our numbers smaller. So we take that 16, we hit it with the 1/4. Negative 16 times a 4th is negative 4. And now let's keep going, but we want to make sure that, you see, this is subtracting 3. This is 1 minus 3 here, but minus 3, rewrite that as addition, is 1 plus negative 3. We want to think about it that way because we want to make sure we're following our sign rules. And negative 3 times negative 4 is positive 12. Now all that's left to do is add the 1, which is 13. Not subtract the 1, because that was attached to this 3. And the times negative 4 did away with that. Negative times a negative is a positive, right? So you have to be very careful when we evaluate these, but in the end, you should get 13. Does my calculator do this? Well, yes. Usually calculators these days are built in to have order of operations pre-programmed. Not all of them. Not all of them, but most of the good ones, all the TI 83s and 84s, that kind of thing, those have order of operations built inside. But you should be aware that some of the cheap ones don't, right? Some of the cheaper calculators will simply fail to do order of operations if you plug it in all at once and hope for the best. Also, a very common error is to miss out on some parentheses when you're putting things into the calculator. Now, some calculators have what we call pretty print. It'll make it look like a fraction, but it's very common to miss out on what's called implied parentheses. Implied parentheses are just another one of those little invisible symbols in mathematics that you need to be aware exist. They come up a lot in fraction notation. If we have a sum or a difference in the denominator or the numerator of a fraction, and there's a quotient bar, so this big long fraction bar between them, that is saying that you are dividing the numerator by the denominator. And so the numerator and the denominator are naturally grouped. And if you want to plug that in the calculator, you better be grouping them by parentheses, right? We do 6 plus 6, 3 plus 3. That's actually 12 over 6, or 2. If you were to miss that, and just type in 6 plus 6 divided by 3 plus 3, okay, great, but that's not right, because your calculator knows order of operations, and this expression here is not the same as the one above. It actually just does the 6 divided by 3 first and gets a 2, and then adding those things together gets 11, which would be the wrong answer. That's not the same thing as what this is. So be careful when you put this in a calculator. Make sure you're putting parentheses around your numerator and denominator. This is such a common error, I'm making it part of your critical notes. So copy this down into your critical notes. When you have addition or subtraction even in the numerator or denominator, you need to put parentheses around those things. So one final note, one of your problems on the online quiz is going to have some brackets and braces. Braces are these little squiggly guys here. Brackets are the ones inside. And they're sort of like just other parentheses, but writing larger and larger parentheses or writing the same size parentheses, it gets a little hard to read. And so it's slightly more readable to use a different symbol. I don't much care for that. I find myself more often just using nested parentheses. But these happen often enough, and so you should be aware they exist. These are just fancy parentheses, and they work the same way. Whenever you go to evaluate parentheses, you want to go to the innermost set first and work your way out from there. All right, so here are your praxis exercises. Pause the video at this time and try to work them out on your own. Okay, let's see how you did. The first thing I would do here is I would dive inside this parentheses and I would evaluate the 8 times 4. But let me copy it first. This is 4 squared plus 2 times -3 minus 8 over 4 parentheses divided by 5. So we would start with this innermost parentheses term, 8 over 4. We go inside the parentheses, then we reevaluate PEMDAS. There's no more parentheses. There's no more exponents. And so we can go to the next line here, dividing 8 by 4. Now, I would remember this negative sign is attached to the 8, so that's going to be -2. And so we have -3 minus 2 inside, and then copy everything else down. You want to get in the habit of copying everything else down and just taking your time, making as many moves as you need to do this right. Now, there's a parentheses here, so what I'm going to do is evaluate that next. So everything else can get recopied except the parentheses. Inside I have -3 minus another 2 gets me down to -5. And now let's, before we move on, take care of the only exponent we have. This parentheses has nothing inside to do. It's just going to be times the 2. So really that should be done with multiplication. But the exponent here we could take care of right now. That is 16. Copy everything else. Now, you can go up in the notes if you want to see a little bit more work on the subject, but the bottom line is that I'm going to do my multiplication and division in any order I like here because division is just multiplication by a reciprocal. Specifically, I have -5 divided by 5. I can do that right now. So this is 16 plus 2 times -1. Negative divided by a positive is a negative. And -1 times 2 is just -2. So this is going to become 16 minus 2. Let's finish it. All that remains is subtraction, and that subtraction gives me 14. This last one over here, let's do the parentheses implied first. That's 10. The bottom one's 10. You should have gotten 1. All right, that's it for this video. Thank you for your patience. Have a great day. Good luck with your studies, and I'll see you in the next video.